Hello, math humans. We're going to start our chapter on quadratic functions with 2.1a today. Our objectives are that we're going to talk about the characteristics of quadratic functions. We're going to convert between standard and vertex form, and then we're going to find the max and the min or the extrema of a function. So let's start off with the basic equation for a quadratic function, and that is y is equal to ax squared plus bx plus c. A is called the leading coefficient. It is also the vertical stretch factor or shrink. We'll put that in there, stretch or shrink factor. And C is going to be the y-intercept, okay? All right, a quadratic in its original form would be located here. This is the vertex, and we're going to call it H and K. All right. It is also, if you look at this particular parabola, it is also the absolute minimum. And depending on the direction of the parabola, that determines whether the vertex is an absolute min or an absolute max. Alrighty. There's several different forms of an equation when we talk about parabolas. My verbiage is a little bit different than the books, but having used many PreCalc books over the years, this is going to be the verbiage that we're going to use. Vertex form is going to be y is equal to a times x minus h quantity squared plus k. Notice that this is called general form. Sometimes it's called standard form. Okay. Vertex form is glorious for graphing. Notice that the a in general form is the same a. And now in this form, our vertex is going to be h and k. So it makes graphing the parabola significantly easier. Alrighty. Several different books use different verbiage, so you want to make sure that you understand, for me, because I'm going to be the one grading your papers, that this is vertex form. And then the last form that we want to see, I'll change colors just to make it a little bit different, is factored form. And this has uses when maybe we're plotting and we'll have want to write down the expression in factored form. It's going to be y is equal to x minus a 0, and then maybe we'll call that the first 0, and then x minus the second 0. Okay? This has its own specific purposes. If I want to go from factored form to vertex form, all I have to do is expand, right? And then if I want to go from vertex form to general form, then all I have to do is expand this and distribute the a. But if I want to go from general form to vertex form, I have two different methods to do that. So there are two methods. I'll scoot my paper up so you can see, to change between, and I'm going to call it standard form and vertex form. All right, so there's two methods to change. The first method, this is not very technical, but I call it the little formulas. And that said that h is equal to a negative b over 2a, and k, and this is from our vertex, is equal to the function evaluated at h. The second method is completing the square. And completing the square is significantly faster than doing the little formulas. And what I'm trying to force to happen is I want that to happen so I force this to happen so that I can factor. That's the whole purpose behind completing the square. And we will walk back through both of these types of problems. Alrighty, so for example 1, I want you to convert to vertex form, and we're going to use both methods because you need to be familiar with both. The equation that we're going to have, I'm going to have to look at my paper because I stapled over it, is going to be y is equal to x squared plus 8x plus 7. All right. So if I want to do, I'll do method 1 over here, and I'll do my little formulas. I'm going to write h is a negative b over 2a, and k is f of h. So my b is 8, so this is going to be a negative 8 over 2 times 1, which is a negative 8 over 2, which is a negative 4. So now I need to find k, and k is f of a negative 4. So I substitute the negative 4 back into the equation, so it's a negative 4 squared, 8 times a negative 4 plus 7, and when you do that math, you're going to get a negative 9. So your vertex, HK, is now going to be, a negative 4, negative 9. So that wasn't horrible. And so then when I rewrite this in standard form, my vertex form is going to be y is equal to x plus 4 quantity squared minus 9. So that wasn't horrible. Alrighty? So now I'm going to start completing the square, and I often write it as CTS, and I'm going to start it over there. Okay? And so before we do completing the square, I'm going to go back and I'll write the steps out as we do it. This is my favorite. I love completing the square because it's significantly easier than the little formulas. So my original equation was x squared plus 8x plus 7. So the first step is that I want to isolate the squared term and the x term. So basically, I'm putting all of the x things together. So I'm going to write y is equal to, and I'm going to put these two guys together, and I'm going to scoot him over. Okay? So I really haven't done anything other than some rearranging. Okay? If the coefficient of x squared is not 1, then you factor in the squared term and the linear term. Okay? But in this case, we have a 1 in front, so I can skip step 2. Step 3 is you're going to take half of the middle term, which is this one, and then you're going to square it. Okay? So half of 8 is 4. Squared is 16, so I'm going to write a 16 there, and then I'm going to put a negative 16 there. So I have to, that's actually the next step, I'm going to add or, sorry, I know you can't see it, there we go, add or subtract the added amount so that the net effect is equal to 0. So notice that I took half of this term, which was 4, I squared it to get 16, so I added 16 to the equation, so now I have to subtract 16 because I can't change the overall value of the original equation, but I can manipulate it. So now I'm going to do some factoring. This is two perfect squares. This is a perfect square. This is a perfect square. So this is x plus 4 quantity squared. So just to remember, if I square the first term, I get this. multiply these two together and double it, I get the 8. Square this one, I get the 16. And then combine like terms. So a negative 16 plus 7, or 80, is going to be, brain fart, a negative 9. Okay, and so now I'm done. So not significantly different. Let me scoot my paper back down. This is how much room it took me to do the little formulas. This is how much it took me to do completing the square. But I think completing the square typically tends to be a lot faster. All right, so let's do another example using completing the square. So this is going to be our second example. I'm going to have y is equal to 2x squared plus 8x plus 7, and I want to put it in vertex form. And again, I'm going to do it using both methods. Oops. So I'm going to do the little formulas first, just because. So h is a negative b over 2a, so that's a negative 8 over 2 times 2. A negative 8 divided by 4 is a negative 2. Then k is f of a negative 2. So that's going to be 2 times a negative 2 squared, 8 times a negative 2 plus 7. And I'm going to get that k is equal to a negative 1. So that means my vertex is going to be negative 2, negative 1. And then my f of x is going to equal, the a is going to be the same, and then it's going to be x plus 2 quantity squared minus 1. So that's vertex form using the little formulas. All right, so now I'm going to do completing the square. So I'm going to isolate the first two terms, plus 8x, and then I'm going to scoot him over. The leading coefficient is not 1, so I need to factor it out, but I'm only going to factor it out of these two terms. So I'm going to get 2 times x squared plus 4x, leave some space, and the 7 still pushed out of the way. Half of 4 is 2, squared is plus 4, but now I have to distribute 4 times 2 is 8 minus 8, because remember the net effect has to be 0, and then y is equal to 2 times x plus 2 quantity squared minus 1. So completing the square, in my opinion, is really a whole lot faster. And notice if I check this term squared is this, multiply those two together and double it, square the last term. So it really is a nice process once you get the hang of it. Okay, let's do another example. So for this one, we want to find the vertex and the x-intercept of the parabola, and then we're going to sketch. The function is going to be f of x is equal to a negative x squared plus 6x minus 8. And again, to find the vertex, I'm going to do it with completing the square. So that is my preference. So when I do this, first I'm going to factor out a negative 1, x squared minus 6x, leave some space, scoot the 8 over. Half of 6 is 3, squared is 9. This is a negative 9, so that means this is a plus 9. Now I can factor, so here's the negative 1, x minus 3 quantity squared plus 1, and this is my function in vertex form. So now I'm going to answer the questions. The vertex is going to be hk, so my vertex is 3, 1. And now I need to find the x-intercept, okay? So my x-intercept, if you'll remember, is when y is equal to 0. So I'm going to let 0 equal a negative 1 times x minus 3 squared plus 1. So I'm going to get a negative 1 times x minus 3 squared is a negative 1. I took him to the other side. Divide both sides by a negative 1, so I get x minus 3 squared is 1. Take the square root of both sides, and I get x minus 3 is plus or minus 1. and then x is going to equal 3 plus or minus 1. So that's going to be 3 plus 1 is 4, and 3 minus 1 is 2. So those are my x-intercepts. Okay, so up here I'm going to write the x-intercepts are going to be at 4, 0, and 2, 0. Remember, we have to be careful about how we report. Well, now it's really easy because I know all this information. So here's 2, 3, 4. There's 4. Those are my x-intercepts. My vertex, where'd it go? Was it 3, 1? Okay. So here's the 3, here's the 1, there's the vertex. So I know that there is my cute little parabola. And this confirms what we found up here as the original equation, because I know, since the leading coefficient is negative, that the parabola is turned upside down. All right. For our next example, I'll get my paper out of the way. So example number 4, it says write the standard form. And remember, standard form is y is equal to ax squared plus bx plus c of the parabola, whose vertex is 1, 2, so that's my h and k, and it passes through the point 3, negative 6. Okay, so let's talk about what I've been given. So I know that the vertex is going to be 1, 2, so this is my h and k, and then I have a point that the graph passes through, and that's going to give me an x and a y. So I'm going to write my vertex form, so y is equal to a times x minus h quantity squared plus k, and I'm going to substitute in the h, the k, the x, and the y so that I can solve for a. So I'm going to write y, a negative 6, is equal to, I don't know a, x is 3 minus 1 quantity squared plus 2. So then if I start simplifying this so I can solve for a negative 6 and a negative 2 is a negative 8. Oops, I don't need that guy, is equal to a, 3 minus 1 is 2, squared is 4. If I solve for a, is a negative 8 divided by 4, so a is a negative 2. But the question said to write it in standard form. So the first thing I'm going to do is go back to my vertex form. So y is equal to a is a negative 2, and then I had x minus 1 quantity squared plus 2. And now I need to put it in standard form, so I'm just going to distribute. So y is equal to a negative 2, x squared minus 2x plus 1 plus 2. Remember, I square the first term, multiply those two together and double it, square the last term. So this is a negative 2x squared plus 4x minus 2 plus 2. Those guys cancel, and I get that y is equal to a negative 2x squared plus 4x. And that is my standard form of the equation. Alrighty, I have one last example, but we're going to think about just our extrema of parabolas. If I have a quadratic function that's turned upside down, this is going to be the absolute maximum, right? Because that's the highest point on the graph. If I have a parabola that's pointing up, the vertex becomes the absolute minimum. Alrighty, so that just are some things that we need to remember. So now I have a little bit of a longer example. I've pre-written it, so you can pause to write this down, and I'm just going to read it to you. This is a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by y is equal to, and there's your lovely little equation, where f of x is the height of the baseball in feet, x is the horizontal distance from home plate. The question is, what is the maximum height reached by the ball? Now, this is a physics equation. It's really fun to mess with. So without talking about all of that other information, this was where the ball was struck. This is going to be the height of the ball after time, gravity, and the initial upward velocity. Okay? So if you think about this, if you look at the equation, notice that that's just an upside down parabola. The leading coefficient is negative and it's squared. So basically, it's going to look something like that. Here's the ball, except it's going to have a y-intercept. So technically, it would be starting at 3. So the ball is going to go up, the ball is going to come down and hit the ground. The question is, what is the maximum height of the ball? So I'm looking for the vertex of the ball. Well, this is yucky. I don't want to put that in vertex form by hand. So lucky for me, I have a handy dandy grapher, and I'm just going to do this in my calculator. So I'm going to turn my stat plots off to make sure that they're not in the way. I'm going to go to my y equals and clear everything that's there. And I'm going to put in the equation that they gave us, which was a negative 0.0032x squared. And then I have plus x plus 3. And I'm going to do a zoom 6. And then I'm going to hit my on button and stop it. And then I'm going to do a zoom 3 and then it's going to go again. And if you'll notice, I still can't see it, so I'm going to do a zoom 3 again. Now I do a zoom 3, enter. Oh, it's getting closer. It's starting to have some curve, and so I need to do a zoom 3 again. Oh, so close. I think I can do it one more time, and then we're good to go. Nice. So when I look at my graph, I'm trying to find the maximum height of the ball, which is at the vertex. So I'm going to do second, calculate 4 for maximum. I'm going to get to the left-hand side of the maximum. I'm going to go to the right-hand side of the maximum, hit enter, enter, and notice it tells me that the maximum height, so let me label my points. This is 156.250, comma, 81.125. Okay, so it said what is the maximum height of the ball, right? So it says in our equation that I'm looking for the maximum height, and y is the maximum height. Therefore, this is the maximum height that the ball was reached. So I answer the question. The maximum height is 81.125 feet. Always wanting to make sure that we include those directions. So sometimes your calculator can be really handy. Alrighty, that's it for today. I will see you